prepared to do a voltage waveform analysis of the injector signal. This is done by tapping into both of the injector wires using wire crimpers or any means necessary. You are measuring a different waveform, which is called a voltage waveform, and by analyzing it, a different set of characteristics can be derived. This is an intrusive test and involves piercing the wires to get to the copper element. In other words, a physical contact is needed. This type of waveform yields a totally different type of information than the current ramping waveform seen before. We are using the Vantage graphing multimeter. And by using the waveform viewer part of the menu and connecting the black and red leads, we can immediately acquire and capture a voltage waveform from the injector wires. Connect the black and red multimeter leads to each one of the injector wires. If the waveform is inverted, simply flip the leads. Here we have the waveform viewer, which is a setting that allows the technician to graph a waveform. An oscilloscope will also do the trick. But you can do the waveform analysis using only the graphing multimeter. As soon as we get set up, we go to the ground control circuit. And then, we plot the waveform on screen. By centering the trigger level or the small x, you can clearly see the injector waveform now on screen. This is a lot easier than actually plotting numbers using a digital multimeter. Following, we see the trigger mark and the injector waveform inverted. Then, we see the injector open time, which is the space between the two vertical lines. There are 3 points of interest when analyzing injector voltage waveforms. These are the injector pulse width or open time. The injector pulse width can also be determined from a current waveform, as we did before. By using a voltage wave, it becomes a lot easier to determine the open time for that injector unit. The spike, following the injector shutdown vertical line, is clipped by the internal circuitry of the ECM. By studying this spike, we can know if there are shorted injector coil windings within the injector itself. This spike is generated by the self-induced voltage of the collapsing magnetic field around the injector coil. You should not have anything less than 35 volts. This spike is never clipped below 35 volts. In actuality, this measurement is a sign of the general health of the injector coil. If the injector coil windings are semi-shorted, the spiked vertical line is going to be much lower than 35 volts. Next we see the injector pintle closing, or the actual physical closing of the injector pintle. This is not the point of electrical turn-off, which is denoted by the vertical line preceding it. It simply takes the injector pintle a few milliseconds for it to close completely. This delayed time is captured by the graphing multimeter or oscilloscope and plotted on screen. The injector pintle closing point, denoted by the small hump, is indicated here by the yellow dot. Again, this small hump is created by the interference with the collapsing magnetic field on the metal pintle closing. Even though our waveform is inverted, the point is the same. If this point is too far down or close to the zero line, then it is a good indication that it is taking the injector a long time to close. This is a sign of weak injector springs. The small spring inside the injector weakens over time and cause the injector to be open for too long a period. As a result, more fuel is delivered to the engine, skewing the fuel trims and the entire fuel injection control system. If on the other hand this point is too far up or further away from the zero line, then it is a good indication of a clogged injector unit. The less fuel inside the injector, the faster its spindle will close. These readings, however, should only be used as preliminary indicators of a problem. Always follow up on these diagnostic tests with further manual testing to prove your faulty issue. This also includes an injector leak down test and carefully monitoring the fuel pressure drop. A manual injector leak down pressure drop differential of 1 psi points to a clogged injector unit.